It gives you, it's a little bit, I thought, a little easier than the homework in the book, and that was what I was going for. So, how did this go? Did you have any trouble with any of this? Do we need to? Um, why is that? Just a minute. This is really strange. Sorry. That is not what I see here. That's really weird. Hold on a minute. Let me see. What if I refresh? Let's go back. I don't know what's going on. I feel like I'm losing my mind. Okay. Okay, now it's what I see. Okay. Now I'm seeing here what I see up there. Um, and although why is that? Why is that like that? It's weird. Okay. Yeah, I don't know. Why is this stuff down here? Oh, I edited it. Oh, I forgot about that. I moved it. That's right. Oh, that's okay. So that's why it looks so weird. We could just make, can I get rid of that? I'll bet I can. Oh, there, it's gone. Now it's not bothering me anymore. Okay, um, so let's take a look at these two, see how you're doing. And then we'll go over this, we'll go over the test, we'll be happy and we'll be done. So this first one, uh, by the way, this is the sort of thing you should expect on your exam. Things like this that are pretty straightforward. It's nothing crazy. And I was talking to, was it Nolan earlier about this, that you don't necessarily have to be able to identify each of your random variables on the exam. You just have to compute the probabilities. And if you had no idea about a hypergeometric random variable and you looked at this problem before last week, this week, you would still be able to solve it, wouldn't you? I mean, it's a pretty straightforward problem here. We've just named a category of random variables. That's all when we call this a hypergeometric random variable. So when you see this, if you remember it's hypergeometric, great. If you don't fret. It's going to be okay. Oh, sorry, one other thing. Let me show you this before we go on. Someone asked me, I forget who, like about memorizing formulas and so forth. So in the past, I've made like a compromise. And so here's what I've got for you on, this is your actual test. And I'm actually zoomed in this time, not zoomed out like, let's see, zoom over here. Let's get back, come on. Oh, it's up there. There it is. Okay, so here's what I got. I got this little chart on your actual exam. So this is your actual exam. It's already been to the printer, so I've got it in my office. And on it, you'll see you've got the binomial random variable. You've got the negative binomial random variable, the hypergeometric random variable. This is the Poisson random variable, and that's the geometric random variable, along with the expected values, they're labeled, and the variances, if you need them. The only thing I didn't label is I didn't label the rows. So I felt like that was a little bit of a compromise, so that at least you'd have to remember, oh yeah, hypergeometric, binomial, negative binomial. You can label them if you want to. You don't have to, because like I said, you don't have to know the names of these things to be able to do the problems on the test. So you'll have that chart. In fact, that is your exam right there. So you can see the next two, there's a probability of the next two something or other. We don't know. You'll find out. It'll be exciting. But anyway, so let's get back here. This is hypergeometric, but do we care? We really don't. All I care about is answering this problem. I'm selecting 4 fuses at random. What's the probability that more than 2 of them are defective? That's a hard question to answer, so I'm going to do 1 minus the probability that none of them are defective, plus the probability that 1 of them is defective. So that's going to be a lot easier. You should expect to have to do that quite a bit. That's one of my favorite, not my favorite, it's just so useful. It's hard to avoid that particular theorem, the idea of doing 1 minus the opposite. More than 2. Oh, more than 2. Oh, never mind. I don't want to do it that way then. Yeah, if it's more than 2, then it's easier to just do x equals 3 plus probability of x equals 4. Yeah, there's no reason to use that theorem if it's, just because I love it so much. It's kind of like someone using the quotient rule for, and those of you who are going into teaching, you're going to see people use the quotient rule for things like this, the derivative of x squared over 3. You could use the quotient rule for that, couldn't you? It's just way more work than it needs to be. So yeah, just you'll see it. Those of you who end up teaching like calculus, uh, it happens all the time. Once a kid learns the quotient rule, it's like, oh, I got to use it all the time. But yeah, so that I don't have to use the 1 minus theorem. It's easier just to do it like this. Okay, so probability that x equals 3. I've got 7 defective. 7 choose 3. And then the rest of them are not defective. 43 choose 7. No, not 7. I'm choosing 1. Sorry. Okay, so let's just make sure I do this right because I was going way too fast on Monday and I kept making mistakes. So let's go slower. So you're going to choose 3 out of the 7 defective fuses and 1 out of the 43 non-defective fuses. And so that's what that is, and then it's over this. So whether you know that that's hypergeometric or not, that's the probability. You're used to doing this. We've done this so many times. I mean, how many urns have we had? And we never even had some cremated remains of anybody in the urns. It's always marbles. Okay, so then we're going to add this to 7 choose 4. If you want to, you could do 43 choose 0. That's kind of unnecessary. And then 50 choose 4. So there's the answer. The 43 choose 0 is completely extra. You don't need it. But that's, if you write that down, I'm super happy. Because not only do I not have to think too hard when I grade this, but also you got it right.
If I do the summation, is that fine?
Ooh, fancy. That's even better. So you're doing this. Oh, I love it. 7 choose I. 43 choose 4 minus I over 50. That's super fancy. That's really extra. But yeah, it's the same thing. So I think that this is probably, well, I guess that if you get rid of this, probably this is less work to write than that. But you do you. All right, great. Okay, so let's see the variance, and that's we've done before, number 12. So we can come back. I'll see what questions you have. I just want to hit the ones that I want to make sure that we talk about since they're these new random variables: negative binomial, geometric, hypergeometric, that we've categorized now. Let's see. It looks like we already talked about that, so I'm going to skip it unless we need to loop back around. As we move on, we've got this this thing. Once you see, I'm not going to do this one in full, at least unless we have to later, but once you see something like this, 80 every day, and we want to know what's the probability of a certain number during another time period, you should think Poisson, at least for now. Eventually, we'll have another way of going about computing probabilities like this. We'll call it the exponential random variable, but that's a continuous random variable. This one is Poisson. So we'll use Poisson for that. We'll come back to it if need be. I want to categorize these first. Wow, we're going to be choosing fuses until I find 5 non-defective fuses. Well, you're doing something over and over again until you find 5 of them that are fit into a certain category. Yeah. What?
On number 12, not to be going back, is it supposed to be taking 26 classes or 26 credits? And if 26 credits, what do you mean by that?
Oh, good question.
Because that will change the answer quite drastically.
1% or 26 credits. 5 class.
Because I just said it was 6 classes, but
I just don't like classes. 26
Huh.
classes. 26 classes is insane. I was like, this person's dead, is all I was thinking. But
I think I was probably, I actually think when I wrote that, I probably was thinking 26 classes, just because of the absurdity of it. And so that's probably what I meant. If you put 6 classes, that's fine. But I think I was thinking of these music majors, how they have a bunch of, like you can be in Goliards for 0 credits and in, una voce. And then collegians for 0 credits, and then you could play your flute for 0 credits. So you could have all of these 0 credit classes. And so I guess I was imagining some music major in like every ensemble for 0 credits. But yes, but then when I was typing, I was 26. How could that be 26? So I changed it to credits. But yeah, so sorry about that. Yeah, I think I was thinking 20. If you did 6, that's fine. And if we need to do that one, we could do the popular, whoever, whatever, we'll take a vote. However you want me to interpret that is fine. Because it's just for practice. That's all this is, it's just practice. It's fine. All right, sorry to gloss ahead without, so we're all happy with the 26 classes? Well, we aren't. Someone trying to finish up their program early. Yeah, wait, if they were, if let's say it was, oh, 1 credit classes, you could have 26 credits of 1 credit classes. It'd be absurd, but seems like 1 credit classes take as much work as a 2 credit class, at least teaching wise. Anyway, getting back here. So yeah, so when I was rudely interrupted, we were doing fuses until just kidding, until you got 5 non-defective fuses, and it's so this is a negative binomial random variable because you're going to keep doing something over and over again until you find 5 of them. So it's probably easier to think of this as negative binomial, but if you test fewer than 7 fuses, what you could do is you could say, what's the probability that you get it in 5 fuses plus the probability of 6? I guess that's it. So you could do this without knowing this word, just by thinking, what are the probability? Let's say you do 5 fuses. They all have to be good. They all have to be non-defective. So it's 0.7 to the 5th. And then this would be 4, 5. Is it 5? Let me think. Because you have to have one of them has to be defective, but it can't be the last one because you ended up having to test 6 of them. It has to be one of the first 5. So you could reason through this without knowing all the formulas. So you do this 0.7 to the 5th plus then 5 because the defective fuse has to be either the 1st, 2nd, 3rd, 4th, or 5th. Can't be the 6th one. So you have 5 choices for which one it is, and then just 0.3 for the defective one and 0.7 to the 5th for the others. So that's the same as what you would get if you actually use the formula, by the way. So that's what I mean by not necessarily having to make that connection, because you're all pretty smart about you're good with counting. The whole point of classifying and categorizing is that when you categorize and you know that something is geometric, for example, you can use the formula and exploit the formula. But if you don't, it just takes a little bit more time to work it out on your own. So don't feel like just because you don't know that this is negative binomial doesn't mean you can't do this problem. So anyway, those are the answers, or that's the answer, by the way. So I guess since I've already gone over that, does anyone have any questions about 15? Yeah, don't worry, we'll have a chance to go back around, yeah?
So if it's less than 7, you only have to do the formula with 5 and 6 as well?
Yeah, if you're using, you mean if you're using the negative binomial formula?
Yeah, I guess I'm confused on that.
Yeah, let's do it with the formula. So first of all, there's this. This is the non-form. Well, it's going to look really similar, but this is the way of just sort of puzzling through it using your knowledge. Like I said, you guys know probability now, or at least the basics. So this shouldn't be too bad. But let's actually do it using the formula. So R here is 5 because I'm looking for 5. I want 5 successes. The probability of success is 0.7. They I give you the probability of failure up there, but you want to find 5 successes. And so I want to know the probability that x is less than 7, which is the probability that x equals 5, plus the probability that x equals 6. So that's what we're working with. Let's go back and get that formula. It's right here. So here's the negative binomial formula. So you got a minus 1, choose r minus 1 times p to the r times 1 minus p to the n minus r. So as long as I can keep things straight, here we are. Let's see, what did I say? N minus 1. So 5 minus 1, choose r minus 1. Here, I'll write it out. N minus 1, choose r minus 1 times p to the r times 1 minus p to the n minus r. I just scrunched it up there. Sorry about that. But anyway, this is the x equals 5 will be 5 minus 1, choose 5 minus 1, times p to the fifth times 1 minus p to the 0. And p here is 0.7, so I should really change this to 0.7. Let's see, can I do that? There we go. So this will be 0.7 to the fifth and 0.3 to the 0. So that's the probability that x equals 5. And then we add to this 6 minus 1, choose 5 minus 1, times 0.7 to the fifth times 0.3 to the first. So there's that is the formula, that if you use the formula. And if you work out the numbers in the formula, you'll find that 5 minus 1, choose 5 minus 1, that's 4, choose 4, is just 1. So that's why this works, because it's 1 times 0.7 to the fifth. And then this is 5, choose 4. 5, choose 4 is actually just 5 times 0.7 to the fifth times 0.3 to the first. So yeah, this one might not be the best example to be using the formula for. I don't know, did anyone see any other negative binomials down below? I don't know if there are anymore. If there aren't, we can go on the practice test and find. Oh, this is the last one here? Oh, sad. There's negative binomial problems on the practice test for sure. So we'll be able to use the formula on the practice test. So if you're still fuzzy with the formula, is that what you're asking about, is how to use this? Okay, we'll come back to it. So don't let me leave without it. Okay, Poisson, we know Poisson. Okay, so is there anything else from this that you guys need help with? We have Poisson, that's Poisson. Oh, the last one? It's Poisson. Oh.
I was confused by it. Pay up to a maximum of 3.
Nice.
What is that?
Okay, yeah. You know, this came right from the actuarial exam somewhere. This is, if you ever take the actuarial exam, they never have units for money. So that 3, what is it? Is it $3? Is it €3? I think it's because they don't want to, disadvantage other cultures or something. But it's probably like $3,000. I don't know, like how much, what would be the maximum? $3 million? Whatever it is, it's just 3 of something. So they don't give units, which is annoying. Okay, so let's see if we can do this. So we have, let's see, Poisson distribution with a mean of 3. Okay, so that means lambda is 3. The insurance company will pay up to a maximum of 3 per claim. That means that if you exceed 3, the insurance company is just going to pay 3. Okay, so here are the options. The insurance company will either, let's see, the payout, and probability. The payout will either be 0, 1, 2, or 3. So once I make this table, the rest of it you can do yourselves because this is a standard, expectation. You're doing expected value. Okay, so if the payout of 0, the probability of 0 is going to be e to the negative 3. So remember, it's lambda to the 0, e to the negative 3, negative lambda, sorry, over 0 factorial.
Isn't it just asking for expected value?
Yeah, expected value. But to compute expected value, we have to.
Just need lambda?
Yeah.
Oh, yeah. Well, okay. So the lambda is the expected value for the amount of loss for the claim. Okay, so I guess that this might have been a bad one to put. I just pulled this out of my files. Use that as an excuse. But so the way insurance works, I don't know if you've ever had to make a claim, but like I was taking my daughter to college. This is 5 years ago or so, and we were on the Tobin Bridge in Boston, and someone rear-ended us and smashed our van. And so I think that it was a $6,000 or $7,000 loss. I forget what they said, but so like $6,000, let's say. But I have a deductible of $500, so the insurance company only pays me $5,500, despite the fact that it was a $6,000 loss. So, so insurance companies do this. They'll have a maximum. Like if you look at your health insurance, for example, health insurance usually has a maximum of $1 million per year or something like that, just to keep costs down or what have you. I think mine has $1 million per year. There's no way I'm ever going to have that kind of a expenses for health insurance for health. So, so you have two things going on here. You have the loss. So the loss, we'll call that X. X is the loss, and then Y is the payout. And if we're talking about the loss, the average for the loss is indeed lambda, which is 3, because it's a Poisson random variable. See, the amount of loss, so the claim is the loss. How much money is in the claim? So that's what that is. The mean is 3. But the insurance company is going to cap the payout at 3. So if you have a loss of 4, they'll only give you 3. Let's say it's a $4 million loss, then you only get $3 million or whatever it is. So you have a cap in the payout. And so anyway, so the expected value of the payout is different from the expected value of the loss. And so that's what I'm trying to compute here. So I'm using the probabilities for the loss to get the probabilities for the payout. So if there's no loss, there will be a 0 payout. And then if there's a $1 million loss, there will be a, I think it'll be let's see, it's 1 to the 3e to the negative third. Is that right? Because it's lambda to the first times e to the negative third over 1 factorial. And when we get to 3, it'll make sense when we get to 3. Trust me. So with 2, we have 3 squared e to the negative third over 2 factorial is the probability. And now with 3, here's the one that's different. This is no longer Poisson. So we're using Poisson here, but here, everything else, if your loss is 3 or greater, you're only going to get 3. Whatever, $3 million. So what we'll do is we'll just subtract all of this from 1 to get the amount of the probability. So it'll be 1 minus e to the negative third minus 3e to the negative third minus 9e to the negative third over 2. There we go. Yeah, so this is maybe more complicated than most of you would like. Some of you are happy to have it this complicated. That sounds so bad. What I mean is, if you're interested in like studying more actuarial science, probability, that sort of thing, then it's good to have something this complicated so that you get used to it. But most of you are like, let's just get through the whatever it is that we need to do for this. So that's the deal. Now that you have this chart, then you just do what we did to find expected values, multiply payout times probability, and then add up the results, and that's it. So yeah, the complication here is that there's a cap. I mean, that's what this is saying, this maximum of 3 per claim. And this language is so bad, but yeah, this is the way if you ever end up studying for the actuarial exam, and some of you might, by the way, I had a guy, he went through all 4 years as an IME major, so teacher prep. He was gung ho. He was good and he was dynamic. I thought he was going to be a great teacher. His senior year, he came to me right around Christmas time, just before finals, and he said, "I don't want to do it." It's like, what? How? And he's like, "I can't do it. I can't go teach." It's like, what am I going to do? It's like, well, let's try to get you to graduate first. So we scrambled. Me, Dr. Brad helped. And we got him to where he could graduate on time. So amazing. It was a miracle. I got to admit. He ended up going on to grad school in Ball State for actuarial science. He's working as an actuary now at Humana. He's loving his life, doing a great job. So it is, it's not outside the realm of possibility that, I mean, it's probably low probability, but those of you who are thinking, oh, I'm going into teaching, that's my life's course. God might have a different plan for you. So anyway, This is really annoying. So if you ever do study for the actuarial exam, you'll notice that the language is kind of funky. But yeah, the answer, you would just multiply and add now. It's pretty straightforward now. Okay, is there anything else that we need to deal with this before we move on and look for a negative binomial problem on that practice test? All right, let's go look for a negative binomial. Everyone did that, right? Because no one wanted to hand it in because you did it on your iPads. Okay, so I'll just give you credit for it so that that way I don't have to collect half of it and pretend that the rest of you. Okay, so first things first. I dug through my files and I found that in past years I've done different things. I found a couple of practice tests that both overlapped but didn't. They weren't perfect, and so. So I just need to mention a few things. Okay, I'll just be forthright about this. Let me just double check. You know, it just seems so cheesy for me to tell you the details, but you know, I know you're all anxious, so let's go ahead and figure it out. Just a minute. I've got the actual exam here. I just want to double check so I know what, I don't tell you any lies here. Yeah. Okay, so anyway, on the actual exam, you know how this one here, number one on this probability exam 2 practice is like super easy. The one on the actual exam is like that, super easy. It's not cards, it's something else. But if you get it wrong, oh, now if someone does get it wrong, if you get it wrong, it'll be okay. No, it's so easy. Anyway, so if you look at it and you think, wait a minute, that's too easy. No, it is that easy. The one on the number 2 on the actual exam is similar to this. It's like one of these inclusion exclusions. So I put another one of those on there because I liked it. And then let's see what else we got here. Okay, none of that. None of this. Okay, so then, so let's see. So 5. Now, if I circle something, it doesn't mean that it's on there, but I know for sure that this is not on there. The thing that like up here, we're done with this for now. So maybe on the final, we'll do something like that again. So number 5, you might have, because that's sort of a basic probability question. In fact, take a look at this. You know what this is now. We have a name for this. That's a hypergeometric random variable. So yes, for sure, there will be something like that on there. And you can either solve it the way you did before you knew that it was a hypergeometric random variable, or you can do it using the formula, however you want to do it. Yeah, there's none of this either. Let's see. Oh, I like this one, don't I? No. Oh, how many? Do I have counting problems? Just a minute. Because that's a counting problem. Let's see. This is a probability. This is a probability. Just a sec. Probability, expected value. Yeah, I don't think I have any counting problems, sadly. Probability. I'm just double checking. Yeah, I don't see any counting problems. That doesn't mean that this wouldn't be fun to do, but there are no actual straight counting problems. All the counting problems are embedded within probability problems. So if you're looking to minimize the amount of work you do between now and Friday, I guess that's the way you would want to do it. Probability, here again, you've got some erns, and so you should think, oh, maybe that's a hypergeometric random variable. Here I've avoided that stuff on the actual test, because I mean, there's only so much I can ask you.
Doesn't number 7 use one of those like given theorems?
Number 7. Oh yeah, it does, doesn't it? If you know, so this is going to be a conditional probability. Conditional. Oh, you always have to do conditional probability. Let me see. I'll tell you though. I'm pretty sure there is at least once. Here, let's search. Find given. The word given shows up. Okay, that's a different context. Let me try find know. If we know. Yeah, there's definitely. Oh, wait. Yeah, there is. There is there's one. Yeah, there's only one. There's one conditional probability. Just to keep you, on your toes. Make sure you know how to do conditional probability because it's useful for the future. So there is one conditional. Yeah, so let's see. So you can cross out all of this just because there's only so much I can put on it. Let's see this thing. Okay, so I don't have those intervals. So like number 11, I think I already crossed out one like that up here. What else can I get rid of? So, okay, to be honest, um, even though I have a conditional probability, it's not as complicated as this one. So you could do that for fun if you want to. It's a good problem, but we don't have to. It's more along the lines of, that one, even that one is, well, here, if we have two conditionals, I think, yeah, it's probably closer to the number 7, but if you can do number 12, I'm sure you can do the one on the test. Um, let's see, is this, oh, this is not expected. This is, what is this? Um, uh, independent, independence, yeah. We need to know independence. So independent events, that's nice. Let's see, history test. Gretchen makes a mistake. Oh, this is another, okay, this is another conditional. So once again, you can choose. I don't know. You probably could not want if you're short on time, you could skip that, because that's not going to be. And this is definitely a conditional. Wait, no, this is law of total probability. Yeah, skip that. This one isn't even spelled correctly. So 5 students at random. Oh, this one's good. Yeah, this one's binomial. So yeah, yeah, this is a binomial. Oh no, that's hypergeometric. Hypergeometric. Okay, so that one's good. This one's also conditional. I know, there's only one conditional on there. Yeah. Okay, finally, some stuff that's on the test. I know for sure. So here we have expected value and variance. So you have expected value and variance. Another expected value, although you had this on one of your quizzes, I'd used that on a quiz, so you're familiar with that one, I guess, sort of. 10 students, what's the probability that 2 of them? Oh, this one is binomial. Okay, so binomial. The difference between number 20 and number 18 is, well, for one, I didn't spell students right in 18, but in 18, I have a fixed number, 40 students. 7 of them are CCP students. And so I have this group, I'm picking out of that group. For number 20, I have students coming to me, or I have 10 students, and there's a 0.11 chance that they're CCP student, and that's independent of all the others. You see, with number 18, if you have 40 students and I pick one and it happens to be a CCP student, it changes the probability. Like it's a 7 out of 40 chance, and then the next one is a 6 out of 39 chance if the first one is a CCP student. So that one is not, that one's hypergeometric, whereas this one is binomial down here. I know I'm making you dizzy by moving it back and forth. Randomly choose, until I find one. So there you see this one's geometric. Okay, so now we're getting into the stuff that we've actually studied recently. And that's it. Okay, so that's it for that one. I'll come right back to this. I know some of you have looked at it, you have worries and fears, but I want to make sure that we do the same thing for the other one. Let's just review that about half of this I've crossed off saying it's not on the test. Not to say you shouldn't know it, but so like this, number 3, number 4, you can cross out. Number 6, am I recording this? I hope so. Yes, I am. So you can always go to the video if you didn't catch all this, or come by my office tomorrow and I'll help remind you. Number 8, number 9, we're crossing out. And then you have 10 is crossed out, and 11, and 13. Yeah, get rid of this completely. Okay, but then I think the rest, oh yeah, this one was more complicated, so I crossed it out. Oh, number 16, sad. Law of total probability. But yeah, so it looks like about half of it would be good. So yeah, my apologies for not sorting this better, but I wanted to make sure you had something to study from, so I just grabbed something. The reason being that the the answers were already on my hard drive. I didn't have to rewrite them, so that's why I didn't redo it. Okay, so for this test, here's the deal. Anything that's not continuous. So continuous, not on your exam. So here, I'll just quickly do this. You could just change this to other, and then you'd be fine. So we're going to do continuous starting on Wednesday next week, so a week from today. So anything that's not continuous. So let me explain what are the continuous things. Let's see. No. Here. 15 is continuous. You can look forward to doing this after the break. So 15 is continuous. Average rate. Let's see. Fewer than 3 times within the next. Okay. Technically, okay, so letter B, 16B. You could do that one using a Poisson random variable, but technically it's an exponential random variable. So this one is Poisson. This one is technically an exponential random variable. We'll talk about the difference after the break. But so you could cross that off. The Poisson, though, is good practice. Got a fair die. Okay, that one's straightforward. Nice discrete random variable. 5 cards, discrete random variable. All these coins are discrete. Okay, yeah, I love those. Okay, so that's it. So there's just a couple of them. Number 15. So there's a little bit more that I've given you than is actually on the test, because the test is only 4 pages, and if you cut out the stuff I just crossed out, you probably get about 6 pages. So in reality, the actual exam is a little bit shorter. There are certainly not 12, I'll tell you how many, matching at the front. Oh, it's not even at the front, it's in the middle. Looks like there's 10. So I've cut that back. I've cut back the number of questions a little bit. So it's just 4 pages, not 6 or 7. All right, so with that said, let's go back really quick to this one and see if there was anything that was horrifying to you that you just don't know. I don't have to do it fully because I have the answers online. But if there's anything that you were just like, did we really do that? And I'll tell you that we did. So I don't know. Yeah, if not, that's fine. And then we'll go to the other one again, just real quick. Just wanted to make sure I deal with anything. Yeah, now everyone's going to be panicky about the first question. It's so easy. It's like, here, I'll just get here. I'll give you an example. It's even easier than that one. Here, what if I do this? Just a sec. Find a thing here. Here we go. Let's do this. Here we go. No. I have to get dice. I have too many dice. Okay, here's some dice. Okay. I was hoping for like a 12-sided die. Anyway, let's say I roll a 12-sided die. Oh, here we go. I got a 12-sided die. So I roll this 12-sided die. What's the probability I get a prime number? And I would even tell you what the prime numbers are. 2, 3, 5, 7, 11 are prime numbers. So you could work that out, couldn't you? Out of 12, let's see, 2, 3, 5, 7, 11. 2, 3, 5, 7, that's 5. 5 out of 12. So you could do that pretty easily. So that's, yeah, the first one is that simple. So if you get to it and you're like, wait, is that really that simple? Yes. I did that on purpose and don't want you to make it more difficult. Okay, so this one's good. Let's go back to the second one again, just to be sure. Was there anything here that horrified anyone, shocked you, or maybe you haven't looked at it yet? Maybe you haven't. Okay, so one last thing, and then you're all done. And that is that when you get the, where did I go here? There it is. Just a sec. Where's my Moodle? Thought I had Moodle up here. Oh, maybe this is Moodle? Oh, yeah, Moodle. Oh, have you noticed that an owl has appeared in Moodle? What's up with the owl? Oh. Okay, but anyway. Oh, this is not, what is this? This is probability. There it's owl. The owl showed up. Okay, so anyway, you'll see that I have the test 2B practice answers and the alleged answers. So I wrote these up probably a couple of years ago, or maybe 4 years ago. So don't hold me to these. Well, if you find a mistake, don't go bonkers. Just let me know, and I'll check it over and see if it's right or wrong. And you know, you can go through and do your best to see if you can figure it out. All right. Anything else that we need to talk about, or are you all happy? I guess there's only so much happiness. I'll be around tomorrow. If you really want to take this exam early, for example, you want to get it out of the way at like 7:30. I'll be in this room at 7:30, giving exams starting at 7:30, and then I have one at 7:50, 9:10, and then this one. So you really want to come early? Come on early. Join the party. We'll have some fun. All right, I think that's it. I'm going to turn off the recording in case you have special